friends, welcome to Basic Electrical YouTube channel. So in today's lecture we are going to learn module 4 second part, that is 3-phase synchronous generator. So by class number 6 I have done problems on induction motor. So by that topic, so the module 4 first part is finished. So actually last lecture I have said that is problems on induction motor part 3, class number 6 part 3. Totally I done 14 problems on induction motor. Prepare those problems only. And in the end I have said that there is one topic, how to start 3-phase induction motor. By using star delta starter we can operate the induction motor. Actually that topic I thought it was in syllabus, but when I go through the syllabus for this scheme, 21ELE13 scheme, that topic is not included. So last lecture itself is the completion of module 4 first part, 3-phase induction motor. So now in today's lecture we can start module 4 second part, that is 3-phase synchronous generators. Okay, so what are the things we are going to study here is working principle of how this generator, synchronous generator will works, on what principle it works. Okay, and what is the frequency generated by that machine, and later construction of generators. What are the types of generator, how it is constructed, what are its applications, and then EMF equation of generator. So generator means it going to generate voltage. Okay, input is mechanical, output is electrical. So there is an EMF equation. One topic is the EMF equation of generator. So that we are going to study. Along with that, problems on EMF equation of generators only. They will ask problems on EMF equation. Very simple. Only three theory topics: working principle, construction, and EMF equation of alternator. See why I called alternator means there are 3 different names. One is called synchronous generator, otherwise we can call it as AC generator, and another name is alternator. Okay, there are 3 names. If they ask in exam, explain working principle of synchronous generator, you write same thing. Working principle of alternator, also same thing. Working principle of AC generator means same thing. Okay, got it? So last very important topic is only one derivation is there in this module, in this part, alternator, that is EMF equation of alternator, and they will ask problems on that EMF equation. Unique problem. You need not to apply your lot of brain to solve a problem. If you remember one formula, you can easily solve it. However, little bit concept is there, so that we can clearly understand by the theoretical lectures. Okay guys, we can start this topic. So today's topic is explain working principle of synchronous generator or alternator or AC generator. So this question may ask maximum 5 marks. Okay, very easy to explain. See, look at here. Now solution. So what I am dictating, you listen and then write it down in your notes. But on board I will write in a short form. See, DC or AC generator, so it works on the principle of electromagnetic induction. Okay, EMI means it works on the principle of electromagnetic induction. See, electromagnetic induction is very big. In that which principle? So we have 2 types of electromagnetic induction. One is statically induced EMF and another one is dynamically induced EMF. So synchronous generator works on the principle of electromagnetic induction, that is dynamically induced EMF. That is dynamically induced EMF. Okay, so what do you mean by dynamically induced EMF? So whenever a conductor cut the flux, an EMF will be induced in it due to relative motion between conductor and flux. Okay, got it? So to get a generating action, we need a conductor and flux. If there is a relative motion between conductor and flux, then we can predict some voltage will get induced in it. That is called dynamically induced EMF. So the direction of this induced EMF is determined by Fleming's right hand rule. Okay, Fleming's right hand rule. Fleming's right hand rule. Okay, got it? And the frequency of this induced quantity, the frequency of this induced EMF is given by the equation F is equal to PNS by 120. Okay, got it? So how we got this equation? Everything I will explain in detail. Okay, now see, blindly alternator works on the principle of electromagnetic induction, that is dynamically induced EMF. So you write about dynamically induced EMF. Whenever a conductor cut the flux, EMF will be induced in it. Okay, the direction of induced EMF is determined by Fleming's right hand rule, and the frequency of induced EMF is given by F is equal to PNS by 120. This is the only explanation you must write. Rest everything I will write figures. Okay, let me consider a two-pole alternator. So I am writing a two-pole alternator. So draw along with me. So this is a north pole and south pole. So between the lines of between the magnets, there will be lines of flux. There will be lines of flux. Okay. So the direction may be from south to north or from north to south. I am going to write from north to south. Okay. So these are the between the magnets, there is a lines of flux. Now one conductor. Now I am taking for understanding purpose one conductor. Okay. So this is a conductor. So this conductor is rotating either in clockwise or anti-clockwise. Anything you can take. For simplicity, I am going to take anti-clockwise direction. So this conductor rotates in anti-clockwise direction. Now it is at position 1. Okay. Now rotate this conductor by 90 degree. Then the conductor comes here. Okay. Now that we can call it as, see, this conductor rotates with certain velocity. Okay, velocity V. When it rotates by 90 degree, then the velocity will be like this. Now rotate further 90 degree, then conductor comes here, and this will be the velocity. Rotate further 90 degree, then conductor comes here, so this will be the velocity. Now these are the position 1, conductor rotates and reaches to position 2, position 3 and position 4. After position 4, again it comes back to same position, position 1. One rotation completed. Okay. So we know that very well about dynamically induced EMF. So this is a conductor. Whenever the conductor cut the flux, EMF will be induced. Look at here. At position 1, see, the conductor is in the orthogonal axis. See, orthogonal axis is nothing but the axis between two poles. Okay, and it is also called polar axis. Okay, the axis between the two poles is called polar axis. So whenever conductor in the orthogonal axis or polar axis, see, this velocity of the conductor is parallel to lines of flux. Okay, here not visible, so I am writing again here. Okay, see, the velocity of the conductor parallel to the flux. Under that condition, induced EMF will be minimum. Okay, got it? So now conductor rotates by 90 degree. So at position 2, it is 90 degree. See, now this conductor is in the lines of flux. See, now the velocity of the conductor is perpendicular to lines of flux. So whenever the velocity of the conductor is perpendicular to lines of flux, when there is an angle between velocity and flux, velocity and the lines of flux, if the angle is 90 degree, under that condition maximum EMF will be induced. Means the conductor is cutting all the flux. Okay. So at position 2, we can predict some maximum induced quantity. Okay, now at position 3, rotate this conductor further 90 degree. So at position 3, let me write somewhere here. At position 3, see now again velocity is parallel to lines of flux. Under that condition, the induced EMF will be minimum. Why means blindly, see this conductor is not cutting the flux, induced EMF is 0. At this position, cutting the flux more EMF. Okay, at position 3 will get 0 induced EMF. Next, rotate further 90 degree. At position 4, let me take position 4. See, at position 4, after every half revolution, okay, the conductor under south pole goes to north pole and north pole conductor goes to south pole. Like that, the direction going to be changed. So at position 4, see now, at position 4, velocity is perpendicular to lines of flux. Under that condition, induced EMF will be maximum. So maximum, we can write negative maximum because the direction of the current will changes. Okay. See now, again rotate further 90 degree. After 4, again it becomes position 1. At position 1, again velocity of the conductor is parallel to lines of flux. So induced EMF will be minimum. Okay. Now you can join all this. Okay. So you will get a generated voltage. Is it visible, guys? Okay, yes, I think this waveform is visible to you. Okay. Okay, got it? What is this? This is an induced quantity. Okay, induced quantity. So, or induced EMF. This voltage is given to the external load. Voltage is generated. Okay. See, I have written example for two-pole alternator. So, for two-pole alternator, okay, we can write theta mechanical. Otherwise we can write one mechanical rotation, very important. One mechanical rotation, see, one mechanical rotation of this conductor. What we got for a two-pole alternator? We got one cycle of induced quantity. So we can write one electrical cycle. We got one electrical cycle. What is one mechanical rotation? That is nothing but 360 degree mechanical is equal to, what is one cycle electrical? This is also 360 degree or 2 pi radians. So we can also write 360 degree electrical. So what is the concept here? If the conductor is rotated by 1 degree mechanically, okay, that conductor cutting the flux, and we can predict the induced quantity at 1 degree. Okay, whenever conductor rotates 1 degree mechanical, then your induced quantity will be 1 degree electrical. Okay, got it? But the same is not true if the number of poles or alternator increases. Okay, got it? So see, till here you must write. Now I am going to write another diagram, same concept I am trying to explain for 4-pole alternator. That you concentrate, but don't copy down in your notebook. Okay, got it? So same thing I am going to explain for 4-pole alternator. Okay, look at here. So draw 4 poles. Okay, this is one pole and another pole. Okay, one more pole. Okay, I am writing in a simplified manner. Okay, so now the conductor will rotate. So let me take this is a north pole, south pole, north and south. See now this we can call it as, okay, axis, interpolar axis, means the axis between two magnets. So this we can call it as interpolar axis. Okay, please don't write this diagram. You write only this much, till here you write. After conclusion from this figure, I am going to dictate some point that you can write down. Okay. Till then, please watch the video. Don't copy anything. Okay, guys. See now, between north and south poles, so we can write there will be a lines of flux between north and south pole. Okay. Okay, lines of flux. Similarly here, north and south pole, there will be a lines of flux. Okay. Now again from north pole to south pole. Okay, lines of flux. Okay, and again from north pole to south pole. Okay. See now, conductor positions. In a 4 poles, the conductor will have 8 positions. See now, this is the starting position. Okay, position number 1. So this conductor will rotating with certain velocity. So velocity V. I have taken the direction of rotation of the conductor is anti-clockwise. You can rotate clockwise also, no issue. Okay. See now, the conductor moves with certain angle, but this angle is not now exactly 90 degree. It is less than 90 only. From here to here it is less than 90. Conductor rotates with certain distance with velocity V. This is the conductor position 2. Now conductor comes in this orthogonal axis with certain velocity. This is position 3. Next conductor position 4. This is the velocity. Position 5. Velocity parallel to lines of flux. Position 6. This is the velocity. Position 7. Okay, position 7 velocity. Next is position 8. This is the velocity, position 8. See now, look at here. I am going to write all the positions here. Position 1, position 2, 3, 4, 5, 6, 7 and then 8. After 8, again it becomes 1. See guys, concept is simple. When velocity of the conductor is parallel to lines of flux. See, these are the lines of flux from north pole to south pole. When velocity is parallel to lines of flux, no EMF. So induced EMF will be minimum at position 1. Now it is rotated by some angle. I don't know that angle. Whether it is 90 degree or no. Definitely it is less than 90 degree. So at position 2, this velocity is cutting the flux. Definitely some voltage will be there. So we can take that voltage. Some induced voltage will be there. Okay. Next at position 3. See at position 3, what is velocity? At position 3, velocity is parallel to lines of flux. Velocity is parallel to lines of flux. So induced EMF will be minimum. At position 3, induced EMF will be minimum. Next position 4. Again velocity is, see at position 4, velocity is cutting the flux. EMF will be induced, but in negative direction. Okay, EMF will be induced in negative direction because every half revolutions, south pole conductor goes to north, north pole conductor comes to south. See now at position 5, see now velocity is parallel to lines of flux. So therefore your induced EMF will be minimum. At position 5, induced EMF will be minimum. Similarly, position 6. See the position 6, velocity is cutting the flux. So therefore at position 6, you will get some induced quantity. Okay. At position 7, see at position 7, velocity is parallel to lines of flux. So induced EMF will be minimum. At position 8, see at position 8, velocity is cutting the flux. Velocity is cuts the flux. So we will get a negative induced quantity at position 8. After position 8, again it moves to position 1. Again at position 1, velocity is parallel to lines of flux. So therefore, induced EMF will be minimum. Got it? So what is this? This is induced quantity. This we can call it as induced EMF. See now, in this concept, in this 4-pole alternator, one mechanical rotation is equal to how many cycles? How many cycles you got? See, this is one cycle. Okay, this is one cycle and this is another cycle. Okay, 2 cycles. Okay, totally we got 2 electrical cycles. See, mechanical rotation will be always 360 degree only. Electrical cycles will keep on changing depending on number of poles in the alternator. Okay, got it? See guys, for a 4-pole alternator, we got how many electrical cycles? 2 electrical cycles. So one mechanical rotation is equal to 2 electrical cycles. Okay, in general we can write 360 degree mechanical is equal to, very good, 720 degree electrical. Okay, one cycle 360 degree and 2 cycles obviously 720 degrees. See now, what is the concept here? If the conductor is rotated by 1 degree mechanically, EMF will be induced at 2 degree electrically. Okay, 2 degree electrical means position 1 0 degree, position 2 is how much? 45 degree. Okay, from here 1 to 2 there is angle 45 degrees. If mechanical degree is 45, at that degree it going to cut the flux and we get an induced voltage at where? At 90 degree electrical. Okay, got it? So when conductor rotates 45 degree, we get induced quantity at 90 degree electrical. Okay. So next, similarly, when conductor rotates by 90 degree, we get induced quantity at 180 degrees. Okay, got it? So it is having double. Okay, but mechanical rotation will not change. It will be calm. It is always 360 degree mechanical. Electrical cycles changes depending on number of poles in the alternator. So in order to overcome that, we have a standard representation to relate between mechanical and electrical degrees. So that is this one. Theta mechanical is equal to P by 2 degree electrical cycles. Theta mechanical is equal to P by 2 degree electrical. See now you take poles. Number of poles is how much? 2 poles. Put P is equal to 2 here. P indicates number of poles. 2 by 2 is what? 1 degree. Then what is the relationship in 2-pole alternator? 1 degree mechanical is equal to 1 degree electrical only. Now you take 4 poles. Put P is equal to 4 here. 4 by 2 is what? 2. 1 degree mechanical is equal to 2 degree electrical. Got it? Then if you explain the same concept for 6 pole, 6 by 3, 6 by 2, 3 poles, 3 you will get. Means 1 mechanical degree rotation will give 3 degree electrical. Okay, got it? So what you can conclude, if the number of poles alternator increases, okay, the number of cycles also increases. How many cycles? For 1 mechanical rotation, how many cycles we get? We get P by 2 electrical cycles. Okay, got it? For 1 mechanical rotation, we get P by 2 electrical cycles. For 1 mechanical degree, we get P by 2 degree electrical. Okay, got it? So therefore, we can define frequency of the induced quantity irrespective of any number of poles. The frequency of this induced quantity is defined by, what is frequency definition? Cycles per second. Okay, or unit of frequency is hertz. So I am going to consider cycles per second. Okay, so unit of frequency is very important. What I am writing now, cycles per second. So now frequency is equal to, now assuming conductor is rotated 1 revolution, 1 mechanical rotation is equal to how many cycles is required? P by 2 cycles. We require P by 2 electrical cycles. And what is the time taken? What is the time? Seconds means time. What is the time taken to complete this one cycle? This many cycles. What is the time taken? The time taken in second is written as 60 by ns. 60 by ns. Now simplify this. P by 2 into ns by 60. Further this become P_ns divided by 120. So that is what I written starting only. Okay, what is the frequency of induced quantity in an alternator? It is given by P_ns by 120, where P is called number of poles, ns is called synchronous speed. Okay, got it? So don't write this equation. F is equal to 1 by t, 1 by time period. So that is different. Okay, analyzing the alternating quantities. This is the actual frequency from the machine parameters. Okay, poles and speed, at what number of poles and what speed it runs. Based on that, we get frequency. Okay, so per second, how many cycles? Okay, so in a generating station, the alternator going to generate 50 cycles in 1 second. In 1 second, it's going to produce 50 cycles like this. 50 cycles you will get in 1 second. So that is the frequency of our country. Okay, got it? So generally in the generating stations, the alternator going to generate around 11 kV volts. Commonly 11 kV. Other voltage range also available. 3.3 kV, 6.6 kV, 22 kV, 33 kV. But in a normal case, majority of the alternators will generate 11 kV supply. Okay, going to induce and quantity up to 11 kV. Okay, that is RMS value. Understood, guys? So I hope everyone understood. See, what you must write is all in one. I will give once again summary. Synchronous generator works on the principle of electromagnetic induction, that is dynamically induced EMF. It is nothing but whenever a conductor cuts the flux, EMF will be induced in it due to relative motion between conductor and flux. The direction of that induced EMF is given by Fleming's right hand rule. Okay, the frequency of the induced quantity is given by F is equal to P_ns by 120. Later, consider a two-pole alternator shown in the figure. You write this figure. Below that you write this waveform. After that you write notations. One mechanical rotation, one electrical cycle. Till here you write. Similarly you write. Similarly for a four-pole alternator, but don't write that diagram. Okay, one time is sufficient. Same concept, but number of poles is more there. Okay, later you write this. Similarly for four-pole alternator, one mechanical rotation is equal to two electrical cycles. That you can simplify like this. And this is very important. Okay, this is very, very important. In general, theta mechanical is equal to P by 2 electrical cycles. So therefore, the frequency of induced EMF is given by F is equal to cycles per second. Assuming the conductor rotates one revolution, in one revolution we get P by 2 electrical cycles. And second, the time taken to complete one rotation is 60 by ns. Simplify that, we get P_ns by 120. Till here you must write, guys. Okay, I hope this is not much difficult. Okay, you can easily write it. Okay, so please don't write. Okay, you watch the video for understanding purpose. Don't write this much. Okay, write only this part. Okay guys, pause the video, copy down as neat as possible. So meet you on next lecture, construction of alternator. Very, very important topic. Okay, please tell your friends to watch the video lectures. Okay, tell your friends to become a member to watch the video content. Okay, have a nice day. Take care. Meet you on next lecture, construction of alternators. Bye bye. Take care.